Good morning, everyone. So this is my talk after a long time. I'm presenting on any forum, so please be with me. Excuse me if I do anything wrong. Okay. So today's talk is more about API designing and what I think and what things I take care of when I am thinking about any API. And so this talk is all about that. So because of this talk format, I have not included code snippets here, but maybe in future if I'll prepare something for main talk, so there I will be showing you all those things. Okay, so here is some brief about me. So I will not go on this slide, so you guys can read it anyway. And already Anashri has shared lots of things. Okay, so what is an API actually means? So API is a description of your component, means how someone can use your component, how someone can use your library. So you give some I'll say some tools. So if I relate it in real term scenarios, so you have a electricity socket. So that socket is your API where you build some electronics equipment and you plug your equipment there and you get electricity and your electronic equipment starts working with that, and you don't worry about how this electricity is coming to you, how is the wiring behind the scene, where is earthing and all those things. So API is something like that only. So you create something, you write some functions and user can use those. So with this API provides a good abstraction, and it gives you a specification of the components. Like if you are writing some API to connect to some server, external server, so you are telling them, okay, your APIs will be like connect, disconnect, send, receive. So it will give a picture to your user that, okay, so these all things I can do with this and how I should proceed. So if I define it, so we can say it, an API is a logical interface to a software component that hides the internal details required to implement. So you hide your internal details in your side. So what all benefits we get when we use or when we write any API? Okay, so you can hide the implementation that we already discussed, that you hide the implementation, how your background system is going to work. Your users don't know about that. And if you will uh, expose your internal implementation, your code is exposed, internal stuff is exposed. So what will happen is that client may mess up with the code and they will come up with something which will look like a spaghetti. So that is we called a spaghetti code where all the things are jumbled. And when you write API based application, so there you modularize things, that you write one database connection library. So when I'm saying API doesn't only means web APIs. So those are also functions. So those are deployed in web. So that's why they are web APIs. When you write a library and you expose some APIs, so the functions from your library, so those functions are also APIs, right? So it helps you to modularize your system and reduce the duplication, right? So it's easy to change. If you want to change something in your server connection library, your means you can change that behind the scene and your customer will not have to worry until and unless you are changing that public interface. So always remember uh, that until unless you are not changing that public interface, it's fine, you can change anything behind the scene. So what all qualities a good API should have, right? So your API should be modeled with the problem domain. Means your API should expose the domain information for which the domain for which you are writing those APIs. Just for example, we discussed this server connectivity thing. So your APIs are explaining, okay, how I can connect to a server. So it will give you all those details, right? And for a non-programmer who is coming into programming, or who's not an expert, or who just want to know what things are happening, so they understand these things very easily if your APIs are uh, aligned with the domain, so they can also understand all those things. And your API should hide the definition in CPP file, so that we call is a physical hiding. So you write the definitions in CPP file, and you add interfaces in public headers, so your headers are exposed. So it's better not to add code in header files. And you should try to hide your data in a logical way also, using object oriented concept like encapsulation. Okay, that provides a mechanism for limiting access of members to an object. So prefer using what I'll say private members over protected or public one, right? Because if you are writing public, so public member, that user can uh, manipulate with that, they can play with that. So it's always suggested that you add private members, and you add getter setters into that. And again, when you are writing getter, so try to make them constant, right? And if you are adding protected, that also not a very good way, because if you are deriving any class from your uh, base class, so in that case user can still access, means your derived class can still access your protected members. So if you are adding any public or private members, you should have a very strong reason for having that. Otherwise, avoid doing that, right? And in the same way, you try to hide internal implementations, maybe in other CPP files, in other classes, or at least you make them as a private. Your APIs should be minimally complete. When I'm saying minimally complete, means it should not be doing lots of stuff, but whatever it is doing, that it should be doing completely. Let's say when you are writing uh, connect, right? So it should completely connect, it should take care of all those retry and all retry things, uh, and it should do in that connect all only. But it should not, after connecting, it should not start doing something different, like sending some data or sending some heartbeat. So it should not do all those things. So that's why I'm saying it should be minimally complete, and it should be small. It's better to write a small API, so that will be more maintainable, more rememberable, right? Don't overpromise, right? So you don't write something, okay, what I'll say, get get data from server, and now this is the only API you are providing, and everything you are adding into that. Don't do that, because adding features in an API, in an existing API, is easy than removing features from there. So if you will overpromise, you will add lots of stuff there, and at later point of time, you want to remove some API, some functionality from that API. So removal will be very difficult. So if you are in confusion, uh, don't add something different, means add some different API there. Use your virtual functions carefully, because they already have some overheads on in your program, right? So if you are adding, use them carefully, right? And if, let's say, sometimes happens, you in your library you have lots of exposed APIs that may be means that is your core API core library, and that maybe that user will get confused. Okay, hey, there are lots of stuff, so what I should do means I should do I need to remember this. So if let's say you want to add some convenience API, so convenience APIs are almost means those are wrapper, you can say those are wrapper over your library. So you can add those convenience APIs there. You can add one extra class. Don't add your these convenience API in your same core API, right? So you add one extra class there, and in that you can um, add your APIs, wrapper APIs, and there you can club couple multiple core APIs into one API, and you expose this API to your user. So for example, let's say you have some thing like get X data from server, so you can add one convenience class, and you add one get one API get X data, and you inside that you can do send receive whatever you want to do. So by doing this, your user will be knowing that as a business logic, okay, I need to do all these things to get all these data, but they will be not aware of that how you are getting that data. So that's a good way when you are writing your APIs to keep that in mind. And your APIs, whenever you are writing, those should be easy and obvious. So, and when I'm saying easy and obvious, so it means that users should be able to remember those things easily. Means it should not be some very lengthy API which you are writing, or confusing APIs. uh, so these should be short and simple, like connect, disconnect, send, receive, bind. These are very simple. So you can remember that these small words in your mind. So that's a good always for you. Okay, and it should be difficult to misuse. Simple is one thing, but sometimes it's possible that uh, developer or whoever is using your APIs or libraries, they may misuse. So it's your responsibility, is your API's responsibility, that user whatever user is doing, it should not get misused. So for just for example, so if your function is taking some parameter, your API is taking some parameter like okay, connect to server 1, server 2, server 3, like that. If you are having integer value or into your API, in your API, to know which server it has to connect, so prefer enums over integer. So enums will give clarity to user. Okay, it's not number I have to give, I have to provide this server name. And now it's more better if you prefer enum class. So that will give you more type safety and more means it will be more, I will say, difficult to misuse, like that. And avoid using multiple parameters with same kind of types. So if there are something, you should have something to differentiate, you should write something to differentiate that. It should be well documented. Okay, and a good API should be consistent in design approach. Okay, conventions whatever you are using, that should be easy to remember, okay, and easy to adopt. So it's not like if you are using, let's say, camel case in your program, so please use camel case everywhere. It's not like somewhere you are using snake case, and somewhere you are using camel case naming structure, so that will create a confusion. So keep consistency in your APIs, right? And your APIs should not have side effects. So that's we call a term is orthogonal APIs. So it should not have a side effect. When I'm saying this, it means, let's say your API is changing some value, so it should not it should only change that x value x only. It should not change something y. Means you have written, okay, set IP address, so it should only set IP address. Now it should not do something else also inside that. So keep that in mind, it should not have any side effect. Okay. Now the next thing is your code should be robust, resource should have robust resource allocation. So if you are allocating something, some memory in your, or allocating some resource, you are getting some resource, it's your API's responsibility to release that. That's a very common mistake which which we all developers do. So that you should keep uh, you should be conscious of these null dereferencing, double freeing, mixing allocators, okay, memory leaks. You should be taking care of that. And in your API, don't add any kind of platform specific code. Try to avoid that. If you have to do something, do that in your internal part, but whatever you are exposing, that public headers you are exposing, don't do those platform specific thing there. Means it expose that, okay, there are some different API for that, some different API for that, so user will have to take care of that. If you want to do that, if your library is something like that, hide it behind your APIs. Okay. And whatever you are writing, whatever APIs you are writing, whatever classes you are writing, to try to keep them loosely coupled. So means it should not happen that your API 1 is tightly dependent on API 2, or your class A is dependent on class B. So try to avoid these kind of things. The more it's loosely coupled, the more robust your code will be, and more easier it will be to change. That is the important thing, right? So it's, and when I'm saying so to avoid, to achieve this, what you can do, you, there is a very good way to do that is you can think of callbacks, notifications, right? So you can write a function or API in your and you can register that API in your some other module. So in that way, that other module that will not be knowing that what is what this module A is, module B will be independent of that. It will be just knowing that, okay, this is some registered function, and whenever something happens, I have to call this. I don't know what is going behind that scene. So that's a good thing. That's a good way of having loosely coupled modules. And at the end means your whatever you are writing, it should be stable. Your API should be stable, documented, tested, and it, your API should be future proof. So it should, means if you are going to change something in future, it should not break your existing APIs. So that is something you need to take care of. With that, means whatever thoughts I tried to summarize, means I will not give any concluding statement here, because this is something, means all these will not be applicable at the same time, and there is no thumb of rule. So you will have to take care, you will have to think in your means you will have to put your mind working to understand where what is applicable and how you can write a better API than whatever you are writing till now. So with this, that's all from my side. If there is any question, you can ask. And questions are guarantees, but answers are not.
So there is one question I see in chat, which is, are callback functions the same as function pointers?
Yes. So when means in some way I'll say yes, because when you are writing a callback function, callback mechanism, so actually you provide your function pointer to that other module, right? There is only way that you, so you provide the address of your function to other module, that whenever something, some event is happening, you call this address and you execute this code. So that is a function pointer. So you register your function pointer in your in other module. So that is we call callback. Means you registered and some other module will call you back.
All right, that was very enlightening. Now, if there are no other questions, I think we're good to close the session. Thank you all for joining. I will be posting. Okay, there is one more question.
Yep.
Last second. So, how are they related as notification? Is that what you're asking?
Okay, so it's not completely related. So the notification service, maybe I missed to add something there. So notification service, you write one service there, or you can say one module, and that module is responsible for each kind. So for notifying everyone. So if I say that observer pattern you must have used or you must have read, so what you do there is you all the your observer objects, they register for a subject, and whenever something change, that subjects notify everyone. So this is in terms of class, this design is in terms of class. In the same way, when you think in different components, so you create write one notification service all, and you register your subject there, and all objects will say that I want to get notified whenever this value is changed. So it's not that service responsibility to notify them, and whatever the subject is, that will tell notification service, okay, I have some different thing, there is something changed, you can use it. So right now in IoT world, it's, you can say that pubsub is some very good example of, means it's a flavor of this notification service, that MQTT broker. So it's a flavor of so what happens there is your all the components, they subscribe for a topic, and there is some publisher which will publish on that topic, and whoever has subscribed, they will get some notification, that data. So there is a MQTT broker sitting behind in between, so that is a notification service. So there is slight difference. When you say callback, it's one to one, means you set a callback with one module, and that, so it's one to one. So if you have 5 modules, everyone will have to set a callback with them. When you are saying notification service, so that notification service may be running on a socket, or that may be with a file sharing, you are doing using some shared memory, you might be using that notification service. So it's like that. So there is some difference.
All right. Thanks everyone for joining.